Yes, welcome to the very last round of this meeting. Now, the title of this meeting is Quantum Science Technology, and exactly the same name, Quantum Science Technology, will be the world year in 2025, and perhaps we will meet again at many meetings in 25, because we have this announcement, Quantum Science Technology, 100 years of quantum is just the beginning. We have not to go to Helgoland. We can go to many other meetings next in 2025 to be launched at the UNESCO in January 2025. Now, the future is quantum. Everyone knows this. And let's see, because of the second quantum revolution, this makes a new wave of quantum. And this name, second quantum revolution, is even Quantum 2.0 name of the conference this summer. And then you see on the edge of technology revolution, Quantum 2.0 refers to the development and use of quantum superposition entanglement in large engineering systems. So this means the quantum computer, more or less. This is a wave of the new Quantum 2.0. This is a sales argument for the second quantum revolution. Now, this computing is the most reaching and challenging goal in the quantum technology. And in my opinion, quantum computer is a selling point for politicians and agency to put money in science. In reality, the scientific opinion is that quantum simulation will be very important. And the industry, I think the big market at present is still the quantum sensors for industry and really practical application. This will be the very first step in this quantum revolution. No, formally, this was covered by the nanoscience because I worked for a long time in nanoscience. And if you work in nanoscience, this was always quantum physics, but not the quantum 2.0. Now, Bill Phillips discussed already my topic. Originally, I announced the title Quantum Metrology, and we heard already that this story was very successful. In 2018, after a long, long time, all countries worked together. We introduced a new international system of units, and quantum physics dominated this transition from the old metrology SI units to the new one. Therefore, this was a year 2018. In my opinion, 2018 was also very important for Quantum 2.0 because everywhere in the world, there were some programs, some extra programs in quantum science technology. In Europe, we have the quantum flagship, and in the United States, the National Quantum Initiative started. And you know, the reason was to provide a coordinated program to accelerate quantum research and development for the economic and national security of the United States. So national security was always one argument for the Quantum 2.0. And last year, the National Security Memorandum mentioned again promoting United States leadership in quantum computation by mitigating risk to cryptographic systems. So the security was a driving force for the Quantum 2.0. Now you see politics and quantum computer, you cannot separate it. Biden looked at this computer. I tried to look also at the IBM computer, but I was not so successful. I had to keep a distance of at least 3 meters. So in Germany, we have the first quantum computer of IBM, and you see behind the glass protection, like for the Mona Lisa, it's protected. You can see this, and then you can see the heart, the chip with the 433 qubits, the quantum processor, the most modern one. But next Monday, there will be an announcement about the next roadmap of IBM. So let's see how they change the roadmap for the future. Now, quantum computation are everywhere. In quantum computers, we will be flooded by quantum computers because many programs. We have in Germany, the quantum computer in Germany was announced last year in Jülich. but we have not only Jülich, we have also Munich, the Quantum Valley Munich. North of Germany, we have a quantum computer made in Germany from Lower Valley Saxony. So all of them will deliver a quantum computer, but what's the definition of the quantum computer is another question. And in my area where I live in Stuttgart, we have a competence center now for quantum computing at the quantum village, the Ehening, where the IBM computer is. The whole village will be built up for quantum science and technology. So quantum computing supports a lot of competition, but unfortunately some unfriendly competition also between countries, so between regions, because when I look at the Scientific American, China is pulling ahead in global quantum race. New studies suggest an implication for both the future of science and the two countries' political relation. China and United States is a big scientific find, and on Christmas Eve, not only Jesus was born, it was in Beijing, a program was born. And on the 24th of December 2017, the mayor of Beijing announced $300 million project just as a seed money for a new center for quantum information science. So this is the competition, and this started as an unfriendly competition now between these big countries, the United States and China. Now, there will be a Cold War in science and technology because of Quantum 2.0. And already 1 year after the announcement in Beijing, they had this institute shaping the quantum future for a better world. So this is a strategy of the Chinese. And I had the chance to visit last month this institute. And within 3 years, they have built up this room there. Everything was free. This was Saturday afternoon. Everyone is working there. 4 quantum computer systems up to 136 qubits. And in Tsinghua University, there are another 2 quantum computers. So there will be a lot of these systems all over the world. And you see already the competition, the Cold War. They have to produce their own cryostat, the embargo list for all low temperature equipment. There's no service, even at the universities where they work with low temperature. Oxford Instruments are not allowed to make service of the systems. And they have here all microwave equipment is not on the embargo list. So this is a situation, but they are starting now to produce themselves all these equipment. Now, they have about 5,000 daily users, and since I'm working in quantum Hall physics, they have a lot of programs to do some research, and these are publications during the last 3 months, simulating churn insulators on a superconducting quantum processor. And another presentation, they showed me the simulation of the Hofstadter butterfly. This is very